Good evening. Hello, good evening to everyone. Welcome to Gate Academy. So, I am Sathish Kumar Durishetty, Faculty of Instrumentation. So, here I am to teach the topic of temperature measurement today. एक बार चेक करेंगे, आवाज़ चेक करेंगे. Is my audio, video, everything is clear? Somebody please comment there. Good evening, Saurav Sarkar, good evening. Good evening to everyone. Shubham Mathur, good evening. No voice. Hello, good evening. Is the voice is clear? Nidhi Yadav, is my voice is clear? आवाज आ रहा है? Is my voice is clear? आवाज आ रहा है नहीं? All fine, sir. Okay. Shubham, yeah, all are fine. चलो मैं स्टार्ट करूंगा सेशन को. सो इन द लास्ट सेशंस हमने क्या क्या टॉपिक्स डिस्कस किए एक बार चेक करेंगे. सो इन द प्रीवियस सेशंस ऑलमोस्ट वी हैव कंप्लीटेड द फोर सेशंस, 4 to 5 सेशंस. ओके, सो पहले हम सेंसर्स का बेसिक इंट्रोडक्शन लिया है, उसके बाद रेसिस्टिव ट्रांसड्यूसर्स लिया है. हमने रेसिस्टिव ट्रांसड्यूसर्स में एक स्ट्रेन गेज कंप्लीट हो चुका है. देन उसके बाद हमने कैपेसिटिव ट्रांसड्यूसर स्टार्ट किया है. कैपेसिटिव ट्रांसड्यूसर के बाद हमने पीजो इलेक्ट्रिक ट्रांसड्यूसर के पास चले गए हैं. एक सेकंड. अच्छा, ओके. सो लास्ट क्लास थोड़ा पोस्टपोन हो गया ड्यू टू सम टेक्निकल एरर. ओके, सो लास्ट क्लास इटसेल्फ वी कुड हैव स्टार्ट द मेजरमेंट ऑफ टेम्परेचर या पीजो इलेक्ट्रिक. सब लोगों को समझ में आ रहा है आपको मेरा प्रीवियस टॉपिक्स जो कुछ इंस्ट्रूमेंटेशन लोग हैं, इंस्ट्रूमेंटेशन लोगों के लिए और ट्रिपल लोगों के लिए भी ये इंपॉर्टेंट है. आई हैव गॉन थ्रू दिस प्रीवियस क्वेश्चंस जो कुछ मैंने डिस्कस किया है, वो क्वेश्चंस अच्छे से तरफ से प्रैक्टिस करना है, क्योंकि गेट में वही मॉडल चेंज होता है, क्योंकि मोस्ट ऑफ ऑल द क्वेश्चंस आर फार्मूला बेस्ड क्वेश्चंस. ओके, और फार्मूला बेस्ड क्वेश्चंस हमने पीजो इलेक्ट्रिक में सम फार्मूलास लिया है, स्ट्रेन गेजेस में सम फार्मूलास लिया है, कैपेसिटिव में सम एनालॉग प्रॉब्लम्स किया है. सो आई टोल्ड यू इन द फर्स्ट 3 टॉपिक्स इटसेल्फ यू आर गोइंग टू गेट 50% ऑफ द मार्क्स. यस और नॉट? सो हमको क्या क्या खत्म हो गया है अब तक? We have completed strain gauge का related questions. Of course, strain gauge comes under resistive type. Then we have completed capacitive. Why? Because majority of the weightage is coming from capacitive. Then we have completed piezoelectric. Am I right? So piezoelectric. So these are the major things. Everything fine? Nidhi Yadav, Aditya, good evening. Chalo. Now we'll start the most important topic. Okay na? We'll start the most important topic. Ek second. Now we'll start the most important topic, that is temperature measurement. आज का टॉपिक है temperature measurement. So कल हमने स्टार्ट किया. ओके ना? So टेम्परेचर मेजरमेंट में मेजर ट्रांसड्यूसर्स और आरटीडी, थर्मिस्टर एंड थर्मोकपल. एम आई राइट? सब लोगों को ये नाम सुना है ना? आरटीडी, थर्मिस्टर, थर्मोकपल का नेम्स आई थिंक यू हैव सीन, यू हैव earlier also you have come across these words. आरटीडी, थर्मिस्टर, थर्मोकपल. सर नो थोड़ा कमेंट्स दीजिए. गुड इवनिंग राहुल जायसवाल, गुड इवनिंग रेगुलर स्टूडेंट्स, वेलकम. सो जल्दी से जल्दी आप जो कुछ लिंक है वो लिंक आपको दोस्तों के लिए शेयर कर दीजिए. इंस्ट्रूमेंटेशन के लोगों के लिए, ट्रिपल का दोस्तों के लिए भी आप शेयर कर सकते हैं. सो जो कुछ टॉपिक मैंने ये डिस्कस कर रहा हूँ, ये टेम्परेचर टॉपिक इज कॉमन फॉर गेट, इंस्ट्रूमेंटेशन एंड आईईएस के लिए भी इंपॉर्टेंट है. ओके, प्लीज शेयर. यस सर, Aditya, share this link to your classmates and your कॉम्पिटिटिव स्टूडेंट्स लाइक इंस्ट्रूमेंटेशन स्टूडेंट्स एंड ट्रिपल ई स्टूडेंट्स. ओके, चलो, क्योंकि जो कुछ इधर सर्विस कर रहे हैं हम ये यूट्यूब चैनल पर, गेट एकेडमी के यूट्यूब चैनल पर जो कुछ सर्विस हम कर रहे हैं, सो दिस सर्विस हैज टू बी रीच टू मैक्सिमम स्टूडेंट्स सो दैट एवरीबडी कैन बी बेनिफिटेड. Okay na? So under the guidance of the Gate Academy, so we are doing a lot of the best content we are giving to all the students. So contents तो practice करना पड़ेगा ना, सब लोगों को reach होना है. अभी गेट 4 महीने है, ये अक्टूबर है, नवंबर, दिसंबर, जनवरी. ओके ना? So the students who are already preparing for gate exam from the last 1 year 2 years, they can use these sessions as a revision. जो पहली बार गेट लिख रहे हैं, 3rd ईयर के बच्चे, 4th ईयर के बच्चे पहले बार गेट लिख रहे हैं, so they are not suddenly they are came to know that this time 3rd year also eligible. So उन लोगों को कुछ भी इंफॉर्मेशन भी नहीं है. So अभी कोचिंग के बारे में बाहर भी नहीं जा सकते, कोई इंस्टीट्यूट को भी नहीं जा सकते बिकॉज ऑफ द पैंडेमिक सिचुएशन. सो उन लोगों के लिए भी ये फ्री सेशंस बहुत अच्छा यूज होगा. सो ये क्रैश कोर्स जो कुछ है, क्रैश कोर्स सब लोगों की अच्छी यूजफुल की कंटेंट भी जा रहा है, सब लोगों को बहुत अच्छा कंटेंट जा रहा है, बहुत अच्छा फीडबैक ही आ रहा है. Then also please forward to maximum students because most of all the instrumentation students are fed up whether to write the gate exam or not write the gate exam. Okay, even those applied students are also they're having some doubts in their mind, मुझसे होता नहीं होता गेट 2021. So उस समय जो कुछ माइंड में होता है, बच्चों के माइंड में होता है, इंफेरिटी कॉम्प्लेक्स जो कुछ होता है, मेरे से होता नहीं होता. एट दैट मोमेंट ऑफ टाइम गेट एकेडमी पीपल, जो कुछ अनलॉग इलेक्ट्रॉनिक्स फैकल्टी हो, नेटवर्क थ्योरी फैकल्टी हो, मशीन्स की फैकल्टी हो, ईएमटी की फैकल्टी हो, जो कुछ आपको क्रैश कोर्स में कंटेंट दे रहे हैं, मेरी तरफ से वो क्रैश कोर्स नहीं है, मेरी तरफ से वो फुल कोर्स आ रहे हैं. आपको फुल कोर्स आ रहे हैं, ऑलमोस्ट 90% ऑफ द कोर्स यू आर गेटिंग. चलिए चलो स्टार्ट करेंगे. आरटीडी धर्मिष्ठर धर्मोकपल, यस और नॉट? सो व्हाट इज आरटीडी? एवरीबडी कैन कमेंट देयर. रूपक सरकार, anybody can comment there? What is RTD? RTD का मतलब क्या है? RTD stands for resistance temperature detector. RTD stands for resistance temperature detector. मेरे दोस्तों, ये RTD comes under resistive transducer, thermistor comes under resistive transducer. ओके ना? सो RTD का वर्किंग प्रिंसिपल क्या है? RTD का वर्किंग प्रिंसिपल है पॉजिटिव टेम्परेचर कोएफिशिएंट ऑफ रेसिस्टेंस. थर्मिस्टर का वर्किंग प्रिंसिपल क्या है? थर्मिस्टर का वर्किंग प्रिंसिपल नेगेटिव टेम्परेचर कोएफिशिएंट ऑफ रेसिस्टेंस. थर्मोकपल का वर्किंग प्रिंसिपल क्या है? थर्मोकपल का वर्किंग प्रिंसिपल है सीबेक इफेक्ट. ओके ना? मालूम है ना सब लोगों के लिए? सो एक बार हम कंपैरेटिव की तरफ से जाएंगे. विल गो लाइक ए कंपैरेटिव. व्हाई? बिकॉज एक सेकेंड. या so if you see the comparative RTD, thermistor, thermocouple. Okay, so some comparative bits are also possible. ऑब्जेक्टिव क्वेश्चंस भी आने की चांसेस है. ओके ना? आरटीडी, थर्मिस्टर, थर्मोकपल पर कंपैरेटिव क्वेश्चंस आने की चांसेस है. फॉर एग्जांपल, द वर्किंग प्रिंसिपल ऑफ आरटीडी इज पॉजिटिव टेम्परेचर कोएफिशिएंट ऑफ रेसिस्टेंस. उसका मतलब क्या है? एज अ टेम्परेचर इंक्रीजेस resistance also increases. As a temperature increases, resistance also increases. So positive TCR means as a temperature increases, resistance increases linearly like this. Okay na? Thermistor follows negative TCR. thermistor follows negative TCR. That means what? As the temperature increases, resistance decreases exponentially. Okay ना? समझ में आपको? As the temperature increases, resistance decreases exponentially. See, sometimes objective questions are expected, दोस्तों. So that's why I'm writing all these things. Exponentially, the resistance is going to be decreased. Okay na? So this is the working principle. Let us take this as working principle. Okay na? So this is a working principle. Whereas thermocouple works on which principle? Thermocouple works on Seebeck effect. Thermocouple works on Seebeck effect. See, आपको मालूम होगा गेट 2019 का क्वेश्चन है ये. गेट 2019 में एक सिंपल क्वेश्चन पूछा, थर्मोकपल वर्क्स ऑन डैश इफेक्ट. सर नो सब लोगों को मालूम है. సతీష్ గోపాల్ దాస్ ఎలా ఉన్నారు సార్? సతీష్ గోపాల్ దాస్ నేను బాగున్నాను. ఓకే, మీరందరూ బాగున్నారు కదా? ఐ హోప్ ఆల్ ఆఫ్ యూర్ ఫైన్. హీఈస్ ఆస్కింగ్ హౌ ఆర్ యూ సార్? ఇన్ తెలుగు హీఈస్ ఆస్కింగ్ ఎలా ఉన్నారు. సతీష్ గోపాల్ దాస్, వేర్ ఆర్ యూ ఫ్రమ్? गुड इवनिंग. कृष्ण चक्रभारती, गुड इवनिंग. हाउ आर यू? हाउ इज योर प्रिपरेशन गोइंग ऑन? चलिए नाइस. सो ये गेट 2019 में क्वेश्चन पूछा है. गेट 2019 में क्वेश्चन पूछा है. क्या क्वेश्चन पूछा है? सीबेक इफेक्ट, थर्मोकपल का वर्किंग प्रिंसिपल क्या है. सो समटाइम्स ऐसा थ्योरी क्वेश्चंस भी आ सकता है. इट्स अ वेरी प्योर लक. हमारा सेंसर्स, हमारा इंस्ट्रूमेंटेशन में एक मार्क का क्वेश्चन आता है. समटाइम दे आर रिलेटेड टू कंप्लीटली वर्किंग प्रिंसिपल, सिंपल वर्किंग प्रिंसिपल. ओके ना? चलो, नेक्स्ट कम्स दिस इज RTD, resistive type. So what is the type? This RTD is passive type. Why? Because it is resistive. Resistive means passive. Thermistor is also passive. Whereas thermocouple is active. ये पैसिव एक्टिव क्या है? कोई भी कमेंट कर सकते हो उधर? फ्रॉम IIT धनबाद, थर्ड ईयर बीटेक ट्रिपल ई. सतीश गोपाल दास, ओके, IIT धनबाद. ओके, you can prepare this for your gate exam. Which branch is this? Omkar Tiwari, it is instrumentation. Yeah, can anybody comment? Can anybody say what is passive transducer and what is active transducer? Anybody? Passive transducer and active transducer. Can anybody comment that? Passive transducer and active transducer. What do you mean by passive transducer? So what is the transducer definition? Transducer means which converts non-electrical to electrical. Okay na? So in the process of conversion of non-electrical to electrical, if the transducer uses external supply voltage, then it is called passive transducer. हम उसको क्या बोलते हैं? पैसिव ट्रांसड्यूसर बोलते हैं. समझ में आपको? In the process of conversion of non-electrical to electrical, if the transducer requires external supply voltage, क्योंकि non-electrical to electrical conversion करना भी एक टास्क है ना, वो टास्क करने के लिए मुझे बाहर से कुछ एनर्जी रिक्वायरमेंट है, तो उसको क्या बोलते हैं? पैसिव ट्रांसड्यूसर बोलते हैं. So what are the examples of passive transducers? All resistive, inductive, capacitive transducers are passive transducers or not? All RLC transducers are passive transducers. क्योंकि जो कुछ हमने पढ़ा है, स्ट्रेन गेज, RTD, थर्मिस्टर, ये पूरा पैसिव ट्रांसड्यूसर्स होगा. नेक्स्ट, व्हाट इज एक्टिव ट्रांसड्यूसर? सेम, in a process of conversion of non electrical to electrical, if the transducer does not require external supply, no external supply, then it is called active transducer. समझ में आपको? So this is also एक 1 mark question है, sometimes एक 1 mark question पूछ सकता है एग्जाम में. Very good, very good. With the self generating transducer because they self develop. Very good Nidhi Yadav, correct. Sathish Das, yes. I attended your classes for Gate 19 AS Kolkata. I hope. Yes. I remembered you, Das. I remember you. Chaliye. So active transducer does not require external supply. So can you give me some examples of active transducer? All of you. Can you give me examples of active transducer? I need some examples. So very good interaction. I need some examples of active transducers. Examples. या उसको हम क्या भी बोलते हैं, उसको हम सेल्फ जनरेटिंग भी बोलते हैं. We'll call them as self generating also. समझ में आपको? And these are called energy consumers. ये हमको एनर्जी कंज्यूमर बोलते हैं, इसको सेल्फ जनरेट. वेरी गुड. So piezoelectric crystal is an active transducer. Next, thermocouple is an active transducer. And solar cell इसको हम बोलते हैं PVC, photovoltaic cell, वो भी एक्टिव ट्रांसड्यूसर है. नेक्स्ट कम्स pH इलेक्ट्रोड भी एक एक्टिव ट्रांसड्यूसर होगा. समझ में आपको सब लोगों के लिए? क्योंकि समटाइम्स आपको एक 1 मार्क क्वेश्चन पूछेगा. मनीष, हाय मनीष, हाउ आर यू? आई थिंक मनीष यू आर फ्रॉम दिल्ली. मनीष, या. सो ये 4 एकदम रिमेंबर करना है, क्योंकि ये वेरी सिंपल क्वेश्चन है. आपको आईएएस में पूछ सकते हैं, गेट में भी पूछ सकते हैं. समटाइम्स 1 मार्क का क्वेश्चन भी आने की चांसेस है. सी जो लोग ईसी पीपल है, ट्रिपल ई पीपल है, ये क्रैश कोर्स उसके लिए आईएएस प्रीलिम्स के भी अच्छा तरफ से यूज होगा. क्योंकि प्रीलिम्स में आपको 13 to 14 क्वेश्चंस आएगा, ऑब्जेक्टिव क्वेश्चंस आएगा, बहुत सिंपल क्वेश्चंस आएगा, सिली क्वेश्चंस आएगा. क्योंकि आप ईसी है ना, उसने क्या क्वेश्चंस पूछता है? इंस्ट्रूमेंटेशन का बेसिक क्वेश्चंस पूछता है. ऋषभ स्वरूप क्लास कब तक चलेगी? क्लास 11 बजे तक चलेगी. आज 9 to 11, ओके ना? आज 9 to 11. चलिए shall we go for the questions now? चलो, क्या हो रहा है इधर? एक सेकंड. एक सेकंड. चलो, now we'll go for the questions. Sub, I think all of you have your booklets with you. PDF है ना सब लोगों के पास? So now directly I'm going for the questions. एक सेकंड. Please, all of you get ready with your booklets. Yeah. So we have completed this particular strain gauge, and now we are moving to piezoelectric also over. Now we'll move to this particular topic. चलो, so पहले क्वेश्चन ये करेंगे, क्वेश्चन नंबर 27 करेंगे. We all go for the question number 27. We'll go for question number 27. Yeah, question number 27. Question number 27. Please open your booklets. Rahul Jaiswal, Rishabh Swarup, please open your booklets. Let us go for the question number 27. A thermometer at room temperature 30 degrees Celsius is dipped suddenly into a bath of boiling water of 100 degrees Celsius. Okay, na? So what is asking? A thermometer at room temperature of 30 degrees Celsius is dipped suddenly into a bath of boiling water of 100 degrees Celsius. It takes 30 seconds to reach 96.5 degrees Celsius. The time required to reach a temperature of 98 degrees Celsius is dash. कैसे करना है ये प्रॉब्लम? कैसे करना है? Question number 27 of your booklet. Question number 27 of your booklet. जल्दी कर दीजिए, रेस्पॉन्स दीजिए जल्दी. Response please. सब लोगों को दिखा रहा है क्वेश्चन नंबर 27. आई एम आस्किंग क्वेश्चन नंबर 27. या कैसे करना है? Please give some response so that I can understand you are able to see the question. Question number 27. A thermometer at room temperature of 30 degrees Celsius. I am starting with question number 27. I am posting here question number 27. Okay na? A thermometer at room temperature of 30 degrees Celsius is dipped suddenly into a bath of boiling water of 100 degrees Celsius. All are able to get the question number 27? Please comment over there. Please comment over there. I'm waiting for your comments. Yeah, Rishabh Swarup, Rahul Jaiswal. Question number 27. मिला question number 27 मिला? क्या हो गया? A thermometer at room temperature of 30 degrees Celsius dipped suddenly into a bath of boiling water of 100 degrees Celsius. It takes 30 seconds to reach 96.5 degrees Celsius. Yeah, good evening, Ashu. The time required to reach a temperature of 90 degrees Celsius is dash. कैसा करना है ये question? Question मिला राहुल जायसवाल? Yeah, please tell me how to solve this question. This question is related to what? This question is related to what? This question is related to control system topic. Time constant calculate करना है sir. Yeah, time constant calculate करना है. कैसे करेंगे? First of all, listen. This is a thermometer which is at room temperature 30 degrees Celsius. Okay. Now I am placing this thermometer in a hot water bath of 100 degrees Celsius. Will it become suddenly 100 degrees Celsius? No. Why? Because thermometer is a slow instrument. Thermometer is a first order instrument. It takes certain time to sense. So if you see the basic working of thermometer, suppose this is the graph with respect to time. I am taking thermometer. Okay, I am taking thermometer. So this is the final temperature to be reached actually. So as per the question क्या है? As per the question, it is initially at a temperature of, it is initially at t is equal to 0, it is initially at a temperature of how much? 30 degrees Celsius. 30 degrees Celsius. It is dipped in a water bath of how much? 100 degrees Celsius. So can I say T final is 100 degree Celsius? T final is the 100 degree Celsius. एक बार क्वेश्चन के पास जाएंगे. So a thermometer at room temperature 30 degree Celsius is dipped suddenly into a bath of boiling water of 100 degree Celsius. It takes 30 seconds to reach 96.5. How much time? क्या हो गया? एक सेकंड. At T is equal to 0, it was 30 degree Celsius. So this is the final temperature to be reached. Okay. So it reaches slowly. So now if you see this graph is just like capacitor charging curve. So for a capacitor charging, what is the equation? Voltage across a capacitor at a particular time is given by V final plus V final plus V initial minus V final into e power minus t by tau ना. Am I right or not? सब लोगों को समझ में आ रहा आपको? So Vc of t. निधि यादव, this graph is similar to capacitor charging curve क्योंकि ये T final है. T final is equal to 100 degree Celsius. समझ में आपको? So T final is equal to 100 degree Celsius. T final is equal to 100 degree Celsius. So now by using this expression, can I write the same expression? Temperature indicated by the thermometer at a particular time is equal to T final plus T initial minus T final into e power minus t by tau. The same equation we can use it or not, just like capacitor charging curve, we can use the same equation. Yeah, now he has given some information for us. Initial temperature is 30. So this initial temperature is 30, final temperature is 100, and he has given in the question if you check, it takes 30 seconds to reach 96.5 degrees Celsius. It takes 30 seconds. Something is happening. 1 second. See, it takes 30 seconds. So I can write T of t is equal to T final plus T initial minus T final into e power minus t by 2. Okay. So T final is 100. T final is 100. T initial is 30, T final is 100, e power, it takes 30 seconds of time, tau we don't know, it takes 30 seconds of time to reach how much? It takes 30 seconds to reach how much? 96.5. What is happening here? We'll see one thing. Try to go through that question. I will sort out this issue. Yes. I'll switch off. Let us see. There is a problem with the maybe system. I can sort it out. Yeah. Just a second. Yeah, this was a question. I think now we can solve. Very good. A thermometer at room temperature 30 degrees Celsius is dipped suddenly into a bath of 100 degrees Celsius. It takes 30 seconds to reach 96.5 degrees Celsius. Now let us go. So temperature at a particular time, sorry for the inconvenience here, sometimes ऐसा होता है, T of t is equal to T final plus T initial minus T final into e power minus T by 2. This is the question number 27. जल्दी से जल्दी करेंगे, टाइम वेस्ट नहीं करना. But I want to give you a hint for the students who are EEE and ECE. I want to give a hint. This is the time, this is the temperature. At T initial, let us take a T is equal to 0 seconds. Initial temperature shown by the thermometer, let us take 30 degrees Celsius. So this is the T initial. The T initial is 30 degrees Celsius. Now the T final is going to be reached at the last. T final is equal to 100 degree Celsius. See, thermometer is a first order instrument. All heating instruments are first order. Remember, the students. All thermal. Font size clear, beta? Font size is okay. Font size is okay. Font size is okay. Font size is okay. Chalo. All thermal systems are first order. All thermal systems are first order. Okay na? So first order systems will maintain a time constant. Okay, Rishi Swarup is telling option B. So let us take this is the graph, and he has given it takes 30 seconds to reach how much? At T is equal to 30 seconds, it reaches how much? 96.5 degree Celsius. Now I can use this T final 100, T initial 30, T final 100 at a time 30 seconds. Tau we don't know, it reaches 96.5. So from this we can find out the tau. Can anybody tell me the answer tau? Rahul Patel, Aditya एक बार चेक कर दीजिए tau कितना आएगा. So please find out the tau first. So yeah, next क्या पूछा क्वेश्चन में? If you see next question, thermometer at room temperature 30 degrees Celsius suddenly into hotter water bath of 100 degrees Celsius. The time reached to reach the temperature of 98 degrees Celsius. ऐसा भी कर सकते. So the time required to reach 98 degrees Celsius. जल्दी से करेंगे. So what is the time reached to reach 98 degrees Celsius? Same equation. So what is the time required to reach 98 degrees Celsius? T T final is 100, T initial is 30, T final is 100. This time he is asking what is the time reached. So tau इधर से substitute करेंगे. Can anybody tell me what is the answer for tau? I am waiting for your answers. What is the tau? Aditya, tau is 10.1 seconds. Please tell me the answers. What is the tau? Yeah, tau is 10.01 seconds. Calculate करेंगे. Please do calculation part. All of you must do calculation part. Yeah, 10.014. Nidhi Yadav, correct. And what is the time here? So if you substitute t here, tau here, what is the time? The time कितना आ रहा है? Please tell me. 35.6. Okay, 35.6 seconds आ रहे हैं. all of you correct. एक बार check कर दीजिए. 35.6 seconds. Option C is the correct answer. All of you understood this question? राहुल जायसवाल एक बार चेक कर दीजिए, जल्दी से बोलिए क्योंकि कैलकुलेशंस आप करना है. आई एम गिविंग ऑल द मेथडोलॉजी. प्लीज बी इंटरेक्टिव. कैलकुलेशन आप करवाइए, जल्दी करो. All of you please do the calculation and tell me the answers. 35.6. Shall we go for the next question? Fast. Shall we go for the next question, Ashu? Krishna Chakrabarti. Please, all of you must carry calculator, otherwise I have to do the calculation. Nidhi Yadav, any other answers? 35.6 seconds is the final answer. Any cross answers you are getting? Anybody, any other answer you are getting, you can type there. Yes sir, next question. Chalo. Now we will go for the next question. So before going to the next question, we will see the first order mein ja rahe hain humne. Let us go in the order as per the topic order. Yeah, if you see this question, first we will see this question, analog questions, the combination of analogs. Yeah, see this question, question number 41. Question number 41. Question number 41. All of you have the booklets with you na? Yeah, Nidhi Yadav, correct. 35.58 seconds. Question number 41. How to solve this question? How to solve this question? See, I will use now सही है? The question is visible to all now? Is the question is visible to all? Now the question is visible to all? Yeah. Please try to solve this question number 47. In the circuit below, this is question number 41. Question number 41. Question number 41. क्या दिया है question? जब दो तीन गैप आया ना, इसलिए थोड़ा practice कम हो गया. So don't mind about that. All of you able to see the circuit? Please give me response. All of you able to see the circuit? Maximize कर दिया मैंने. I hope all of you are able to see the circuit. Chaliye. In the circuit below, the op amp is ideal. Okay na? So dear students, if you see, this particular op amp is ideal. So he has given this op amp as ideal. So this op amp is ideal op amp. So ideal op amp, so ideal op amp को some features होता है ना, ideal op amp को some features होता है. So in the question क्या दिया, in the circuit below the op amp is ideal and the sensor is an RTD whose resistance is given by expression R theta is equal to 1000 into 1 plus 0.004 theta ohms, where theta is temperature, the output sensitivity in millivolts per degree Celsius is dash. ये क्वेश्चन कैसा करना है निधि यादव? Yeah, how to do this question? Have you seen this question is a combination of RTD plus, this question is a combination of RTD plus op amp. Am I right? This question is a combination of RTD plus op amp. So if you see this particular question, let us approach in this way. I hope all of you are able to see this. Now if you see this picture, question क्या पूछा? The output sensitivity पूछा. Output sensitivity in millivolts per degree Celsius. I think all of you understood this is RTD now. This is the RTD. So what is the theta? Theta is the temperature. So आपको मालूम है ना RTD का इक्वेशन क्या है? RT is equal to R0 into 1 plus alpha delta T ना कृष्ण चक्रवर्ती. Yes or no निधि यादव? RT is equal to R0 into 1 plus alpha delta T ना? Yes or no? जल्दी बोलिए, इंट्रैक्शन प्लीज. RT is equal to R0 into 1 plus alpha delta T. वही फॉर्म में है ना ये भी? 1000 into 1 plus alpha 0.004 theta ohms na? Yes or not? So that is in the same form of the RTD expression or not? Yes or no? So कैसा कैलकुलेट करना है? He is asking sensitivity in millivolts per degree Celsius. क्या होता है? Because of the temperature, RTD resistance changes. When RTD resistance changes, this V0 also changes. So काम करेंगे. Let us take theta is equal to, question asked for 1 degree Celsius ना निधि? Rahul Jaiswal, question asked for 1 degree Celsius ना Rahul Jaiswal? So question asked for 1 degree Celsius. So एक काम करेंगे, इधर 1 degree substitute करेंगे. If you substitute 1 degree Celsius, what happens? Theta is equal to 1 degree. Yes or no? If you substitute theta is equal to 1 degree Celsius, क्या आएगा इधर? This will become how much? 1000 into 1 plus 0.004 आएगा. So that will become 1.004 into 1000. That means this will become 1004 na. That means what is happening here? So I will erase this. Okay, I will erase this. Now what is the value of this? Now its value is how much? 1004. Agree or not? Yes or no? Getting or not, Aditya? Now if you see this particular part, if you see this current analog, if you see this current, this is a minus 5 volts, this current gets divided here, and the current cannot enter into ideal op amp na. The current passing through this op amp is equal to 0 na. The current passing through this op amp, current entering into the op amp will be 0 na, according to ideal op amp conditions. According to ideal op amp conditions, current entering into this op amp is equal to 0. So whatever the current comes, the same current will come here or not? All of you are there? The same current will come here or not, dear students? The same current will come here. Now we can apply some network theory basic concept. ये दोनों resistor series में है ना? ये 10K दोनों resistor series है ना? So let us take this voltage as V1, voltage across this particular node as V1. Now ये दोनों resistor series में है. Now V1 can be written as voltage across this resistor, that will become 10 kilo ohm by 20 kilo ohm into minus 5 volts or not? समझ में आ रहा है नहीं? I am applying basic network theory, minus 5 volts, that will become how much beta? That will become minus 2.5 volts. So now you got V1 as minus 2.5. So V1 is equal to minus 2.5. Yes or not? V1 is minus 2.5 means what about V2? V2 also minus 2.5 na? Yes or no? So if this is minus 2.5, now with respect to this node V2, can I apply the nodal analysis or not? Node analysis apply kar sakte na? Why? Because current entering, current leaving or not? So what I will do, apply nodal analysis. Apply nodal analysis at V2. So algebraic sum of the currents passing through single node is 0. So can I write V2 minus of minus 5 by this resistance 1 kilo ohm, that means 1000 ohms, plus V2 minus of V0 by 1004 ohms is equal to 0 na? Yes or not? Dear students, what is V2? V2 is nothing but minus 2.5. So if you substitute here, this is minus 2.5 plus 5 by 1000 plus minus 2.5 minus V0 by 1004 is equal to 0. Now if you simplify, you are going to get V0 or not? Yes or no? How many of you understood? Very good, Nidhi Yadav. V1 is equal to V2. Suma Chaitra, okay sir. Yeah. So can anybody tell me what is the answer now? What is the answer for V0? Please tell me what is the answer for V0? Please calculate and tell me what is the answer for V0. V0 कितना आ रहा है? क्या इतना टाइम ले रहे हैं आप? राहुल पटेल, एनीबडी प्लीज आंसर. समझ में आपको मैंने क्या किया? आइडियल ऑप एम्प, these two resistors are in series, so I applied the voltage division. Here the voltage is 10k 10k, so these two are in series. With respect to this I have applied the voltage division, I got minus 2.5. So this voltage and this voltage both are say minus 2.5. With respect to this node, nodal analysis apply कर सकते हैं हम. V2 minus 2.5 minus of minus 5 by 1000 plus minus 2.5 minus of V0 by 1004. Apply करो तो हमको V0 आएगा. I am waiting for the answers बेटा. Yes, V0 is equal to 10 millivolts. V0 is equal to 10 millivolts. All of you understood? That means for 1 degree Celsius change, for theta 1 degree Celsius change, here V0 कितना आ रहा है? 10 millivolts आ रहा है. So sensitivity बोलो तो क्या है? Output by input ना. So sensitivity पूछा क्वेश्चन में, sensitivity of the system is equal to output 10 millivolts per 1 degree Celsius. So answer क्या होगा बेटा? So answer क्या होगा? The output sensitivity in millivolts per degree Celsius is equal to 10 millivolts per degree Celsius. You should type the answer, dear students. Yeah, very good, very good. Nidhi Yadav, इसमें millivolts दिया है. So please see, this is an objective question. Dear students, this is an objective question. Answer should be 10. That's it. There is no other way. The output sensitivity in millivolts per degree Celsius means 10. Don't write in volts. Clear, Rahul? Rupak Sarkar, clear? Yes, Nick, yes. మనం ఎంత రాయాలి? 10 అని మాత్రమే రాయాలి తెలుగు में. I am telling in Telugu. 10, you should write 10 only. You should not write 0.1 volt, 0.021 volt. Okay ना? समझ में आपको? Millivolts per degree Celsius already given. I think all of you understood. All of you understood? Please show me the thumbs if you understood. We'll go for the next question. Chalo, we'll go for the next question. Yeah. See, I am taking an order. I am going in order. Don't worry. I am going in order so that all the questions can be covered in order. Yeah. Can you answer this question? Yeah, this is a circuit given. So this is a circuit given. Let me check one second. I will go for the next page and then I will come back and I will cut this. मैं कट कर रहा हूँ, फर्स्ट सर्क्यूट कट कर रहा हूँ. एक बार सर्क्यूट देखिए, आपका पेज में, आपका बुकलेट में क्वेश्चन नंबर 31 है. क्वेश्चन नंबर 31. चलो इधर आया क्वेश्चन, क्लियर है ना, सब लोगों को दिखा रहा है ना. सर्क्यूट इज विजिबल और नॉट डियर स्टूडेंट्स? या दैट्स इट. सो दिस इज अ क्वेश्चन नंबर 31 का सर्क्यूट है. क्वेश्चन नंबर 31 का सर्क्यूट, क्वेश्चन नंबर 31. या चलो क्लियर. चलो चलो, नाउ दिस इज अ सर्क्यूट. सो दिस इज अवर RTD. This is our RTD. Is the font is clear beta? This is RTD and he has given this as R into 1 plus X and this is minus 12 volts. This is R, this is a V naught. And what is the question? Let us see the question. A resistance temperature detector RTD is connected in a circuit as shown figure. Assuming the op amp to be ideal, if V naught is 2 volts, what is the value of X? See, this op amp is given as ideal beta. This op amp is given as ideal. If V naught is equal to 2.1 volt, if V naught is equal to 2.1 volt, then what is X? Can you do it? Question is completely related to analog. Rajesh Rajan, very good. Question is completely related to analog concept. I am waiting for your answer. फटाफट करेंगे, फटाफट. This question is fill in the blank question. This question does not have any this please ये पेज कट हो गया. नेक्स्ट पेज में सर्क्यूट आया. Before that page you have a question. A resistance temperature detector is connected in a circuit as shown figure. Assuming the op amp to be ideal, if V naught is plus 2 volts, very clearly he has given plus 2 volts, not 2.1, sorry. It is not 2.1. It is plus 2 volts. It is plus 2.0 volts. कर सकते? Let us try, let us try, let us try. चलो चलो ट्राई करो, जल्दी ट्राई करो. I am waiting, I am waiting, I am waiting, I am waiting for your answers. Try, try, try. Analog, basics of analog. He has given op amp as ideal. V naught is plus 2 volts. V naught is plus 2 volts. What is X? Is the font size is clear? Shall I increase the pen thickness? Nidhi, Rupak, shall I increase the pen thickness? Is it okay? I am watching your comments. .2 आदित्य बोल रहे 0.2. Clear sir, it's okay sir. 1 by 5, 0.2. Sir, KCL apply and the value of X is 0.2. Chalo, chalo, very good Ashu. Let us do simple yaar. This is ideal op amp. He has given this as a ground, so 0 voltage at 0, and this voltage is also 0, virtual ground concept. And let us take this voltage is also 0. So this voltage is 0. Now with respect to this 0, we can apply the node analysis. 0 minus 12 by R into 1 plus X. Yes or not? 0 minus 12 by R into 1 plus X. 0 minus of minus 12 by R plus 0 minus V naught by R. Yes or not? So with respect to this nodal analysis, I am writing here 0 minus 12 by R into 1 plus X plus 0 minus of minus 12 by R plus 0 minus V naught. V naught is nothing but 2 volts by R is equal to 0. This V naught is 2 volts. If you substitute and simplify x, you are going to get 0.2 ohms. So the correct answer is 0.2 होगा. मजा आया? Yes, मजा आया? भगवान रेड्डी అర్థమైందా? భగవాన్ రెడ్డి, భగవాన్ రెడ్డి తెలుగు అర్థమైందమ్మా? నీకు బాగు పురింజదా? समझ में आया? Do you understand? అర్థమైందా? These all are same meaning. Very good. Point 2. So this is the beauty of analog, dear students. Analog is a must. Analog, I mean especially op amps. Op amp is the best friend. Op amp is best friend of transducer. Op amp is the best friend of transducer. So you cannot see the questions of transducer without op amp. Okay na? Chalo. Shall we go for the next question? Shall we go for the next question? Yeah. Now I am going in order, dear students. I am going in order. Now let us go for some interesting question. Yeah, ये question देखेंगे. See here. So before this, let me cut this question. I am going back. चलो next page. Going back. Cut करेंगे circuit को. Circuit को cut करेंगे. So up to this will cut. Yeah, this is a circuit beta. I'm cutting this circuit, don't worry. Chalo. So this is our circuit. I think all of you are able to see the circuit. Yeah. Are you able to see the circuit? Chalo. Circuit क्या है? There is a RTD. This RTD is a part of a Wheatstone bridge. Okay na? And this RTD's Wheatstone bridge output is connected to ideal instrumentation amplifier. And question में क्या दिया है? Let us see. देखो, consider a temperature measurement skin shown in the adjoining figure. It uses an RTD whose resistance at 0. So what is given? Resistance at 0. Resistance RTD data. RTD data. RTD information. Resistance at 0 degree Celsius is 100 ohms. Alpha value of the RTD is given as 0.00392 per degree Celsius. 0.00392 per degree Celsius. देखो, consider a temperature measurement skin shown in the figure. It uses an RTD whose resistance at 0 is 100 ohms and temperature coefficient of resistance is 0.00392 per degree Celsius. Now question क्या पूछा? एक सेकंड. Question क्या पूछा? The differential gain of the instrumentation amplifier to achieve a voltage sensitivity of 10 millivolts per degree Celsius. क्या पूछा? 10 millivolts per degree Celsius. एक सेकंड. 10 millivolts per degree Celsius. The differential gain of the instrumentation amplifier to achieve a voltage sensitivity of 10 millivolts per degree Celsius at 0 degree Celsius approximately should be. Do you understand the question or not? What is the question? You know, he is expecting the voltage sensitivity. He is expecting the voltage sensitivity of the system as 10 millivolts per degree Celsius. 10 millivolts per degree Celsius. Voltage sensitivity of the system 10 millivolts per degree Celsius at 0 should be approximately dash. Is asking क्या हम क्या कर सकना है, क्या करना है अभी? Is asking the gain. How many of you understood the question? How many of you understood the question? Ashish Mishra, Rahul Jaiswal, Bhagwan Reddy, Nidhi Yadav. What do you understand from this question? ये क्वेश्चन में 3 स्टेप्स हैं. स्टेप 1 RTD का इंफॉर्मेशन, स्टेप 2 व्हीटस्टोन ब्रिज का आउटपुट, स्टेप 3 इंस्ट्रूमेंटेशन एम्पलीफायर का आउटपुट. समझ में आपको? सो फर्स्ट RTD, सपोज इनिशियली एट 0 डिग्री सेल्सियस. इफ RTD इज इनिशियली एट 0 डिग्री सेल्सियस, का रेजिस्टेंस क्या होगा? 100 ohms होगा. So at theta is equal to 0 degree Celsius. Temperature. If temperature is at 0 degree Celsius, then resistance क्या होगा? R0. resistance will be how much? 100 ohms. समझ में आपको? Now at that time bridge क्या होगा? देखो, this is 100 ohms. निधि यादव, राहुल जायसवाल, समझ में आपको? राहुल पटेल. So this is 100 ohms. So 10k 100 under 10k bridge becomes balanced. Then V bridge will be 0, op amp out will be 0. When T is equal to 0 degree Celsius, R naught is equal to 100 ohms, which gives me Wheatstone bridge का voltage as 0 volts and which gives me op amp का output V naught as 0 volts. समझ में आया? For 0 degree Celsius, 0 volts. If you draw the system, the overall input for the system is temperature. समझ में आपको? Non-electrical quantity is the temperature. And the overall output is V naught. Yes or no? When T is equal to 0 degree Celsius, V naught is equal to how much? 0 volts. समझ में आपको सब तक? Up to this it is clear सब लोगों के लिए? सुबर्णा कुमारी, निधि यादव, understood sir, very good, very good. Now what is the question asked? Question देखो, to achieve a voltage sensitivity of 10 millivolts per degree Celsius, बोलो तो क्या है? At 1 degree Celsius, it should be how much? That means if you are expecting at 1 degree Celsius, at 1 degree Celsius change, इधर आउटपुट कितना आना है? 10 millivolts आना है. ऐसा आने के लिए कितना गेन होना चाहिए? To get an output of V naught 10 millivolts, मुझे गेन कितना होना चाहिए? कैसा करना है? एक क्वेश्चन कैसा करना है? बहुत अच्छा क्वेश्चन है ना, लेंथी क्वेश्चन है ना, क्वेश्चन में खतरनाक कॉन्सेप्ट्स है ना. कैन यू टेल मी हाउ टू डू दिस क्वेश्चन? आई एम वेटिंग. व्हाट आर द स्टेप्स? व्हाट आर द स्टेप्स इन्वॉल्व्ड? व्हाट आर द स्टेप्स इन्वॉल्व्ड इन सॉल्विंग दिस क्वेश्चन? जल्दी बोलिए. व्हाट आर द स्टेप्स इन्वॉल्व्ड इन सॉल्विंग दिस क्वेश्चन? समझ में? क्वेश्चन समझ में आपको? एक आरटीडी है, एक आरटीडी इनिशियल का टेम्परेचर 0 डिग्री सेल्सियस पर, उसका रेसिस्टेंस है 100 ohms. इफ दैट टाइम इफ इट इज केप्ट इन द ब्रिज बैलेंस होता है 100 into 10k, 10k into 100, V bridge will be. So T is equal to 0, R naught is equal to 100 ohms, V bridge will be 0 volts, V naught will be 0 volts. At 0, 0. Now he is asking, I want to get a sensitivity of, sensitivity बोलो तो क्या है? Change in output to change in input, 10 millivolts per degree Celsius. That means per 1 degree Celsius change in RTD मुझे 10 millivolts कैसा करना है? Yes, calculate new RTD value. Very good, very good. Shall we go? चलो, I'm just minimizing. Don't worry. Yeah. Yeah. Okay. So we'll go step by step. समझ रहे हो आपको? थोड़ा एडजस्ट कीजिए. बोर्ड डिजिटल बोर्ड है ना, थोड़ा समटाइम्स मॉर्निंग से कुछ क्लासेस में रिकॉर्ड करते जा रहा हूँ. आपका पीडी कोर्स का भी रिकॉर्डिंग हो रहा है. आई एम गोइंग टू स्टार्ट ए सेंसर्स. आई एम गोइंग टू रिलीज द सेंसर्स कोर्स बाय द नवंबर 2nd week. यू आर गोइंग टू गेट द सेंसर्स कंप्लीट पीडी कोर्स, पेन ड्राइव कोर्स. 80 hours में डिस्कस कर रहा हूँ. सुबह से वही डिस्कस कर रहा हूँ, सुबह से वही रिकॉर्डिंग कर रहा हूँ, इसलिए थोड़ा सा सिस्टम थोड़ा सा स्मॉल डिस्टर्बेंस आ रहा है. अदरवाइज इट इज एवरीथिंग फाइन. ओके ना? चलो कैसा करना है? स्टेप 1. वेरी गुड. स्टेप 1 करेंगे. स्टेप 1, टेम्परेचर 0 डिग्री सेल्सियस, resistance is how much? Resistance 0, 100 ohms. Now at temperature 1 degree Celsius, what is the resistance of RTD at 1 degree Celsius? We have to find. Am I right? How to find out this? Yes, how to find out this? Which formula? RT is equal to R naught into 1 plus alpha delta T ना, 1 plus alpha delta T. So मुझे resistance at 1 degree Celsius चाहिए. Resistance at 0 degree Celsius is 100 ohms into 1 plus, what is alpha? Alpha is equal to 0.00392, 0.00392 per degree Celsius, 0.00392 per degree Celsius. Delta T is 1 minus 0 degree Celsius. Can you simplify and tell me how much this is value is going to be? How much this value is going to be? Jaldi. RTD value at 1 degree Celsius. Shivam Verma, Ashu, Nidhi Yadav, Rahul Jaiswal, what is the resistance at 1 degree Celsius? Resistance at 1 degree Celsius कितना आएगा? Please be interactive, please be interactive. कितना आएगा? कितना आएगा? निधि यादव, resistance RTD at 1 degree Celsius, resistance at 1 degree Celsius कितना आएगा? Simple यार, 1 into 0.0392, 0.0392 plus 1, 1.00392 into 100, इधर आएगा 2 dots, so 100.392 ohms आएगा, 100.392 ohms आएगा. क्लियर है? 100.392 क्लियर है? चलो स्टेप 1 हो गया. स्टेप 2 क्या करना है? आई हैव टू टेक अ ब्रिज. स्टेप 1 हो गया. नाउ स्टेप 2. व्हाट इज द स्टेप 2? आई विल गो फॉर स्टेप 2. I will take the Wheatstone bridge. If you see the Wheatstone bridge now, this is 10k, 10k, 100, and this is 10 volts, and this is 100 ohms. Now in the place of 100 ohms, we have to take 100.392 ना 10k. चलो step 2 जाएंगे. Step 2. Step 2, Wheatstone bridge. This is 10 kilo ohms. ये वाला हमारा RTD है. कितना है? 100.392. ओके ना, एक सेकंड. और so this is 100, this is 10k 10, 100 10k 10. So this is 100 ohms, this is 100 ohms, this is 10 kilo ohms, and this is our 10 volts, and this is the ground, and we have to solve the V bridge. If you see, this is the plus terminal, so I can take this as a plus terminal, I can take this as the plus terminal, and this is a minus. सही है? All of you understood? Understood? Very good. Very good. Very good. Yes sir. 100.392. Now जल्दी बताइए, what is a V bridge? V bridge कैसा कैलकुलेट करना? 10k, 10k, 100 ohms, 100.392 ohms. Please, all of you must carry calculators with you. You must carry calculators with you. आपके पास calculators होना है. Calculators से करवाइए. V bridge कैसा करना है? This is network theory. So if you see, this is an open terminal. The main current gets divided here. So current cannot enter here. So these two resistors are in series or not? These two resistors are in series, and these two resistors are in series. Now with respect to ground terminal, if I write V bridge, that is nothing but V plus minus V minus. So what is V plus? With respect to this ground, if I write 100 point, let us take the voltage division rule. apply कर सकते हैं ना? We can apply the voltage division rule or not, दोस्तों? Very good. VDR, रूपक सरकार. Very good. लगे तार सब. Done. So we have to apply voltage division rule. These two with respect to ground, let us do. So voltage across this resistor is equal to this resistance by total. That means I can take 10 into 100.392 by 100.392 by, yeah, this is 10k. 10k means 10,000 plus this is 100.392 minus, with respect to this, 100 by 100 plus 10,000. Please simplify and tell me the answer with respect to this. Fatafat. I want the answer. Nidhi Yadav, Subhadra Kumari, Rupak Sarkar, Aditya. I am expecting the answers. Please tell me the answer. $100.392. 100.392 plus 10,000 by 100.3 कितना आ रहा है? प्लीज जल्दी. टाइम लगेगा कैलकुलेशन के लिए, because this calculation takes certain time. So please find out this V bridge. ओके ना। सो वी ब्रिज कैलकुलेट करने के बाद स्टेप 3 क्या है? स्टेप 3, व्हाट इज द स्टेप 3? स्टेप 3, so what is the step 3? This Wheatstone bridge output voltage is going as an input to whom? Op amp. So V bridge is going as an input to op amp. Op amp output is V0 and is expecting the op amp output as 10 millivolts. Differential gain we have to find out. V bridge जल्दी से जल्दी कैलकुलेट कीजिए. So हमको differential gain आएगा ना? समझ में आपको? Yeah. Please take 0.38426. Excellent. Shivam Verma, you are correct. 0.38426. 0.38426. Units क्या है? Units बताइए. Units volts or millivolts? Units बताइए. 0.38426 volts or millivolts? Volts or millivolts? Very good. 0.38426 volts or millivolts बेटा? Millivolts. Yeah. 0.38426 millivolts. Okay. 0.38426 millivolts. So V bridge here we are getting as 0.38426 millivolts. 0.38426 millivolts. So AD कितना होगा? 10 millivolts divided by 0.38426 millivolts. millivolts कैंसल, कितना आएगा? आंसर चेक कीजिए जल्दी. वेरी गुड. सो अभी डिफरेंशियल गेन कितना आएगा? सुभद्र कुमारी, राहुल कुमार, सब लोग हम. ऑल ऑफ यू प्लीज टेक व्हेनेवर यू आर डूइंग दिस टाइप ऑफ कैलकुलेशंस, एक बार इधर देखिए. सी एक बार इधर देखिए, हम ऑप्शंस में क्या है? 13.41, 26.02, 57.53, 90.14. He's asking the differential gain. That means he's asking the AD value. He's asking the AD value. Okay ना? कितना आ रहा है भैया? Some people are telling 3.8426. See calculation part here to take care beta. 26.0. Very good. So option B is the correct answer. 26.0. समझ में आपको? मजा आया? कितना स्टेप्स है देखो बेटा, 3 स्टेप्स है प्रॉब्लम में. 3 स्टेप्स है प्रॉब्लम में. सो स्टेप क्वेश्चन और एक बार मैं एक्सप्लेन कर रहा हूं. एक आरटीडी इज एट 0 डिग्री सेल्सियस इनिशियली द ब्रिज बिकम्स बैलेंस. V bridge will be 0, then V0 will be 0. Now per 1 degree Celsius change here, he is expecting 10 millivolts here. Then he is asking what should be the gain. So पहले स्टेप में मैंने क्या किया? पहले स्टेप में मैंने स्टेप 1 में रेसिस्टेंस एट 1 डिग्री सेल्सियस को कैलकुलेट किया. सो रेसिस्टेंस एट 1 डिग्री के लिए दिस इज द इक्वेशन यू हैव टू रिमेंबर दोस्तों. RT is equal to R0 into 1 plus alpha delta T. उससे हमको ये इक्वेशन आया, 100.392 आया. ये पहला स्टेप है. सेकंड स्टेप इज व्हीटस्टोन ब्रिज. व्हीटस्टोन ब्रिज में 100.392 सब्स्टिट्यूट किया बेटा. 100.392 सब्स्टिट्यूट करके व्हीटस्टोन ब्रिज को सॉल्व किया बेटा. दैट इज 0.38426. एंड थर्ड स्टेप में एंड दैट 0.38426 गोइंग टू ऑप एम्प का आउटपुट. मजा आया? कितना टॉपिक्स इन्वॉल्व हो गया इधर बेटा? हाउ मेनी टॉपिक्स इन्वॉल्व हो गया? हाउ मेनी टॉपिक्स हियर? This is related to our sensors. I mean sensors and transducers. And this is related to Wheatstone bridge is related to measurements. Wheatstone bridge is related to measurements. And next comes op amps. Op amp is related to beta analog. Okay, ये मेरा साइन है. Sensors, नेटवर्क थ्योरी और ऑप एम्प. एंड उसके बाद आता है नेटवर्क थ्योरी, सिग्नल कंडीशन सर्किट बोलते ऑप एम्प. हम बोल सकते हैं उसको ब्रिजेस. ब्रिजेस मीन्स विल कम अंडर इलेक्ट्रिकल मेजरमेंट सर्क्यूट्स, मेजरमेंट्स. नेक्स्ट कम्स ऑप एम्प. मजा आया? चलो चलो, एंड रिमेंबर डेटा, दिस इज क्वेश्चन नंबर 1। और एक क्वेश्चन है उसमें, और एक क्वेश्चन भी है, और एक क्वेश्चन भी है। चलो लेट अस गो फॉर द क्वेश्चन। चलो, नाउ इफ यू सी दिस क्वेश्चन, if you see this question, question number 35. The RTD placed in hot water bath of temperature 100 degrees Celsius. Now what he is doing? The RTD means what? The previous RTD. The RTD means the same RTD. This 34 and 35 both are interlinked questions. The RTD placed in hot water bath of temperature 100 degrees Celsius based on the gain calculated in the previous problem. The error in the measurement of temperature is dash. एक कैसा कैलकुलेट करना है? क्या समझ में आपको? क्या समझ में आएगा आपको? In this question क्या दिया है? The RTD is placed in a hot water bath of temperature 100 degrees Celsius based on the gain calculated in the previous question. The error in the measured value of temperature due to bridge non-linearity. कुछ समझ में आपको? एक क्वेश्चन में क्या पूछ रहे, कुछ समझ में आया? The RTD, previous RTD, whose resistance at 0 degrees Celsius is 100 ohms, whose alpha value is 0.00392 per degree Celsius, and whose op-amp differential gain is 26.02. Okay na? And that RTD is now placed in hot water bath. Hot water bath of how much? 100 degree Celsius. अभी क्या होना है डियर स्टूडेंट्स, कैसा करना है? क्वेश्चन समझ में आपको? डियर listen 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 listen, yeah, come to this. See, previously at 0 degree Celsius कितना आया? V0 0 आया. At 1 degree Celsius कितना आया? 10 millivolts आया. अभी पूछ रहे क्वेश्चन, he is asking for what you know, he is asking for what you know. $100 degree Celsius को आना है. Do you understand? Subhadra, Nidhi Yadav, Amit Paswan, all of you understanding what I mean? He is asking at 100 degree Celsius. At 100 degree Celsius कितना होगा? At 100 degree Celsius कितना होगा? Dear students, as per the linearity, let me थोड़ा सा इधर देखो, as per the linearity, देखो ग्राफ देखो, let us take this as the T, this as the V0. सब लोगों को दिख रहा है ना? Is it visible to all? T and V0. देखो, listen. Yeah, at T is equal to 0 degree Celsius, this is in millivolts. 0. At T is equal to 1 degree Celsius, at T is equal to 1 degree Celsius कितना? 10 millivolts. At T is equal to 100 degree Celsius, as per the linearity, बेटा as per the linearity कितना होना? As per the linearity कितना होना? If 0 degree Celsius ऐसा है, yes or not? As per the linearity, at 0 degree Celsius 0, at 1 degree Celsius 10 millivolts. बोलो तो 100 degree Celsius को कितना होना है? Please tell me. As per the linearity, Nidhi Yadav, very good. At 1 degree Celsius 10 millivolts. Simple logic ना? 1 rupee 10 chocolates, 100 rupees कितना chocolates होगा? 1000 millivolts होना है ना? 1000 millivolts. So as per the linearity, you should get 1000 millivolts. Am I right or not? When the RTD is placed in 100 degree Celsius water bath, it should get 1000 millivolts as per the linearity. See, when RTD is equal to 0 degree Celsius, here 0 millivolts. When RTD is equal to 1 degree Celsius, here 10 millivolts. When RTD is at 100 degrees Celsius, it should be in 1000 millivolts. Am I right? Am I right? Mazaya? Yes. This is a true value. Subhadra, very good. This is the true value or not? Can I say this is a true value? This is a true value. समझ में आपको? Yes or no? True value. So this is a true value. हमको measurement निकालना है. Measurement कैसा निकालना? Same circuit now we have to keep. Yes or no? So what I will do now? Step 1. RTD resistance of RTD at what temperature निकालना है? 100 degree Celsius निकालना है. Yes or no? Yes or no? At 100 degree Celsius निकालना है. So we have an equation RT is equal to R naught into 1 plus alpha del T. So RT is equal to resistance at 100 degree Celsius we want. So let us remove this. So we want resistance. जल्दी से जल्दी बताइए भैया. Resistance at 100 degree Celsius मुझे चाहिए. So R naught is 100 ohms and 1 plus alpha is 0.00392 per degree Celsius. Okay na? Delta T is equal to 100 degrees Celsius. Celsius cancel. 100 means 0.392 plus 1. 1.392 into 100. It will become 139.2 ohms. है correct है ना? Correct है नहीं? Yes or no? Very good. Subhadra, don't round off. Subhadra, don't round off. Please don't round off. Don't round off. Don't round off. Okay ना? Don't round off. अगर आप round off किया सुभद्रा, आपका रैंक को भी वो round off करेगा, आपका मार्क्स को भी वो round off करेगा. चलो 139.2. So step 2 क्या होगा? Step 2 will take a Wheatstone bridge. Yeah, this was 10 kilo ohms. This is our RTD. अभी कितना है RTD? 139.2. Okay ना? देखो ब्रिड्ज देखो 100 ohms ना? Yeah. So this is 100 ohms. This is 10 kilo ohms. So this is a supply. This is a ground. Supply कितना दिया है? 10 volts. So this is a plus terminal. This is a minus terminal. Yes or no? Now we have to calculate V bridge or not? Now we have to calculate V bridge or not? Very good. So how to calculate V bridge? Shall I continue here? I am continuing here. So let us take the continuation steps now. So same method, V bridge. My dear students, मैंने strain gauge का chapter में Vs by 4 into del R by R4 formula निकाला. Vs by 4 into del R by R formula. Do you remember this? Do you remember this formula? So जो लोग मेरा strain gauge का topic attend हो गया, उन लोगों को पहचान लगेगा ये topic. Vs by 4 in del R by R. But can I use that formula? Ashu, can I use that formula? No problem, no problem. No problem, Subhadra, no problem. Why? Because question is related to error na Subhadra. Question is related to error. That's why errors will change with just a small points na. That's why I'm telling. Yeah. Can I use this formula? My question को answer कर दीजिए. Vs by 4 into del R by R, can I use it? Shivam Verma, can I use? Yes sir. Surat, Stuart, can I use that formula? My question is, a quarter bridge है, वो क्वार्टर ब्रिज में 4 रेसिस्टर्स होता है व्हीटस्टोन ब्रिज में, इनमें से एक रेसिस्टर चेंज हो गया बाय डेल आर. देन कैन आई यूज दिस फार्मूला Vs by 4 del R by R? Stuart says yes. Ashu says yes. How many of you say yes? Sir, I am from electrical. Okay, no problem. Shivam Verma, आप इलेक्ट्रिकल है तो इलेक्ट्रिकल में व्हीटस्टोन ब्रिज आए ना, इलेक्ट्रिकल में भी व्हीटस्टोन ब्रिज आए ना. मेरा क्वेश्चन क्या है, एक व्हीटस्टोन ब्रिज में 4 रेसिस्टर्स रहता है, 4 रेसिस्टर्स में अगर एक रेसिस्टर चेंज हो गया, No sir, very good Bhagwan Reddy. This formula cannot be used because this formula is useful if and only if all the resistors are equal. All the resistors are equal, then only. But in this question, all the resistors are not equal now. This is 10k, this is 10k, this is 139.2, this 100 ohm, they are not equal beta. The resistors are not equal. No sir, we can't use. Yes. Subhadra Kumari, this particular formula is useful if all the resistors are equal initially and one of the resistor is changing by del R, then only. Vs by 4 into del R by R formula when to use if all the resistors are equal initially and one of the resistance is changing by del R, then only. Yeah, ఇక్కడ రెసిస్టెన్స్ డిఫరెంట్ కదమ్మా, ద రెసిస్టెన్స్ డిఫరెంట్గా ఉన్నాయి, ఈ రెసిస్టెన్స్ अलग अलग है. देखो 10k 10k 100 1, so we cannot use this formula, we cannot use this formula, so we have to go for Wheatstone bridge का voltage division rule करना पड़ेगा. We can use steps used in previous part to solve this. That means VDR voltage division rule apply करना, VDR rule apply करना. So कैसा करना VDR जल्दी, सप्लाई वोल्टेज 10, ओके एक सेकंड, या बताइए. या 10 विथ रेस्पेक्ट टू ग्राउंड करेंगे, दैट मीन्स 139.2 डिवाइडेड बाय 139.2 प्लस 10,000 ohms माइनस 100 by 100 plus 10,000 ohms. Am I right or not? Am I right or not? Please solve this. Please solve this. Jaldi. I'm expecting answer from your side. Armati says 38 millivolts. Please tell me accurately, Bhagwan Reddy. Bhagwan Reddy, are you from Telugu? Please tell me accurately. Not don't round off. .0382 Telugu. Okay, 0.038288. Accurate sir. Shivam Verma. Units बताइए Shivam Verma. Shivam Verma units. I will take Shivam Verma's answer. It looks so accurate. Units. Shivam Verma, I am asking units. .038288 units. Oh. Which is the correct one? Point millivolts. 0.038288. 0.038288 millivolts. Let us take this as a standard. Okay. Sorry, volts. Volts. Okay. Right. So I am taking volts. Okay. Now where this particular output will go? Step 3 क्या है आप बताइए. Step P क्या है? Where this output is going? Step 3. Where this output is going? This particular output is going to op amp na. So this V bridge is going to op amp. So 0.038288 is going to op amp, whose differential gain is how much? 26.02. Then what is the V0? So this is a differential gain. So what is the V0? So V0 will be AD into V bridge. So please simplify and tell me what is the answer. 26.02 into 0.038288. Answer कितना आएगा? यस, डिफरेंशियल गेन इज 26.02, राइट। मैं समझ में आपको, मैं क्वेश्चन पूछ रहा हूं आपका आउटपुट कितना आएगा, आई एम आस्किंग यू आउटपुट कितना आएगा, आई एम आस्किंग यू आउटपुट, या 0.9964 volts, very good, 0.9964 volts, that means you are getting 996.4 millivolts, 996.4 millivolts, am I right? 996.4 millivolts. Don't round off, Ashu, don't round off. Very good, Shivam. 0.996431, very good. 0.996431, I will take 996.4. This is, can I call this as our measurement value? चलो, या ट्रू वैल्यू कितना है, 1000 millivolts. अभी मेजरमेंट वैल्यू कितना आ रहा है हमको, लेट अस से मेजरमेंट वैल्यू हियर, मेजरमेंट वैल्यू हमको आ रहा है 996.4 millivolts. So now there exists a error or not? There exists error or not? निधि यादव, क्वेश्चन समझ में आपको? स्टुअर्ट, वेरी गुड, -0.4 डिग्री सेल्सियस, एक्सलेंट. अमन तिवारी, सर एक क्वेश्चन, वेट अमन तिवारी, just wait, don't ask in the middle. Nidhi Yadav, very good. So this is 996 point, this is a measurement value, this is a true value. So what is the error? As per the linearity, you should get, as per the linearity, true value should be 1000 millivolts, but measurement value you are getting as 996.4 millivolts. Then what is the error? Error is equal to measurement value minus true value, that is 996.4 minus 1000, that will be coming around how much? 4 point something, कितना आ रहा है? 3.6. So this is coming around 3.6 degrees Celsius, 3.6 millivolts, am I right? 3.6 millivolts. Minus, yes or not? Minus 3.6 millivolts, am I right? Yes. But if you see the questions options में डिग्री सेल्सियस में दिया है, ऑप्शंस में क्या दिया है, डिग्री सेल्सियस में दिया है. कैसे कैलकुलेट करना ऑप्शंस में? दैट मीन्स व्हाट, सी एज पर अवर प्रीवियस 10 millivolts per degree Celsius, that means what, per 1 degree Celsius 10 millivolts. समझ में? लास्ट स्टेप इज मोस्ट इंपॉर्टेंट. एक्चुअली उसको 1000 डिग्री सेल्सियस 1000 millivolts दिखाना है, 1000 millivolts corresponds to 1000 डिग्री सेल्सियस, लेकिन आपको 996.4 millivolts दिखा रहा है, दैट मीन्स दैट इज सिमिलर टू 99.6 डिग्री सेल्सियस होगा ना, ऐसा भी कैलकुलेट सकते. 1 डिग्री सेल्सियस corresponds to 10 millivolts means 1 millivolts corresponds to how many degree Celsius? 0.1 degree Celsius ना. Then 996 millivolts corresponds to how many? Sorry. Here हमारा एरर कितना आया? 3.6 millivolts. Sorry, 3.6 millivolts corresponds to how much? 3.6 millivolts. 3.6 millivolts corresponds to how many degree Celsius? 0.1 into 3.6. Yes, 0.36. That means 0.36. Yes or not? 0.4 roughly. Yes or not? 0.36. 0.366. So this is corresponds to 0.4 roughly, minus 0.4. समझ में आपको? Correct answer is minus 0.4. That means 1000 डिग्री सेल्सियस के लिए 1000 millivolts है. It is showing 996 millivolts, means it is related to 996 degree Celsius. समझ में आपको? It is showing 1000 degree Celsius, sorry 100 degree Celsius కదా, it should be 100 degree Celsius. एक सेकंड 100 डिग्री सेल्सियस के लिए 100 डिग्री सेल्सियस के लिए 1000 मिलीवोल्ट्स आना है. So 996 millivolts means it is representing what? 99.6 degree Celsius. That means how much error? 0.4. मजा आया? निधि यादव, last step do you understand? Stuart, last step do you understand? Very good, very good. Rupak Sarkar, last step do you understand? Shivam, do you understand the last step? So what is the correct answer? Minus 0.4 degree Celsius. मजा आया? चलो चलो, shall we go for the next question fast? Shall we go for the next question? Please show me the thumbs. अगर क्वेश्चन समझ में आपको, आप मुझे कुछ सिंबल्स दे सकते, कुछ आपका पैर चाहिए मुझे. आप 10:30 बजे हो रहा है, इट इज ऑलमोस्ट 10:30. सो योर कमेंट्स एंड योर विशेस एंड योर लव, एवरीथिंग इज एनर्जी फॉर मी. ओके, चलो नाउ हम थर्मिस्टर के बारे में जाएंगे और एक क्वेश्चन विल गो विथ रेस्पेक्ट टू थर्मिस्टर. या ये क्वेश्चन कैसा सॉल्व करना है, ये क्वेश्चन कैसा सॉल्व करना है. How to solve this question? Question number I will cut this. Question number 28. Is it visible? Question is visible now, beta? Yeah. I think all of you are able to see the question. Chalo. Thank you Rahul, thank you very much. Thank you. वो देख के मुझे एनर्जी आ रहा है, बहुत अच्छे एनर्जी आ रहे हैं. चलो सर, यू टीच रियली वेल, थैंक्स अ लॉट. थैंक यू मोहम्मद, थैंक यू. चलो ये क्वेश्चन कैसा करना है, हाउ टू सॉल्व दिस क्वेश्चन. क्वेश्चन नंबर 28. A thermistor, see thermistor has a resistance of 10 kilo ohms at 25 degrees Celsius. So at 25 degrees Celsius, that means if you take this as T0 initial temperature or T1 25 degrees Celsius, at 25 degrees Celsius its resistance R1 corresponds to 10 kilo ohms. Next, and 1 kilo ohm at 100 degrees Celsius. T2 100 degrees Celsius and the resistance R2 is 1 kilo ohm. The range of operation is 0 to 150 degrees Celsius. This is the thermistor. So this circuit is operating in the range of 0 to 150 degree Celsius. The excitation voltage is 5 volts and the series resistors 1K is there. The power dissipated in the thermistor is asking the power dissipation in the thermistor. How to solve this question? Power dissipation. Dear students, let me explain you. Thermistor is working on negative TCR. I think all of you know very well. Thermistor will work on negative TCR. So if you see, this has the initial temperature T1, this is the final temperature T2, this is the initial resistance R1, this is the final resistance R2. The characteristics of thermistors are exponentially down. Yes or not? Why? Because thermistor will follow, very good. First we'll calculate beta, Stuart, correct. So first we should know thermistor characteristics are highly exponentially. As a negative TCR na? Negative TCR. As the temperature increases, resistance decreases. So there is an expression R2 is equal to R1 into exponential of beta 1 by T2 minus 1 by T1. So this is the formula beta. Simple, this is exponential, just like our capacitor discharging curve beta. Capacitor discharging curve, Vc of t is equal to V max into e power minus t by tau na. Same format, same format, same format, same format. सेम फॉर्मेट, समझ में आपको? चलो अभी कैसा करना है? R2 is equal to R1 into exponential beta 1 by T2 minus 1 by T1. So first R2 is given how much? 1. So ये इक्वेशन को ऐसा भी कर सकते हैं, R2 by R1 is equal to exponential beta 1 by T2 minus 1 by T1. Now if you apply natural logarithm, ln R2 by R1 is equal to beta 1 by T2 minus 1 by T1. Okay na? So this is the formula. Now first, what is beta? Beta is the material constant. In the first question, what is the question given? Dekho. In this question, he has given some information. 25 degrees Celsius per 10 kilo ohms, 100 degrees Celsius per 1 kilo ohm. So from these two informations, I can calculate the beta or not. Very good, Stuart. Can you find out the beta? Stuart, beta value should be in the range of, beta is what? Material constant. Beta is a material constant. Beta should be in the range of 3000 to 4500 Kelvin. That is a material constant of the thermistor material. Okay na? So kaise calculate karna dekho. So here, by using this formula, ln, so what is R2? Let us minimize this. Yeah, what is R2? 1 kilo ohm, 1 kilo ohm, R1 10 kilo ohm, beta we don't know. But remember, temperature should be in Kelvin. Thermistor is semiconductor made. Semiconductors will follow Kelvin. So we have to take Kelvin. So T2 is 100 degrees Celsius. 100 means 100 plus 273. That will become 373 Kelvin. T1 is 25 degrees Celsius. That will become 298 Kelvin. Please simplify and tell me what is the beta value. I need the beta value. I am expecting beta value. Stuart. Very good, very good. Stuart, आप कहाँ से हो? What about others? Kumar, Vinod Kumar, Rahul Patel, Nidhi Yadav, Shubham, Subhadra. I'm expecting 4.7 millivolts. Millivolts. Question asked is power. Question asked is power. You are telling millivolts. Yeah, beta value is 3412. Very good. Beta value is 3412 Kelvin. Okay na? So there is a hint always. Remember, beta should be in between 3000 to 4500. Chalo. Now if you see this, sorry. Next question kya hai? The range of operation is 0 to 150. The excitation voltage is 5 volts. Question asked is power dissipation of thermistor at 150. So first of all, he is asking power dissipation at 150. Listen. Is asking power dissipation at 150. What is the power dissipation formula? Power dissipation is equal to I square R. So power dissipation at 150 he is asking. So we should calculate current at 150 and we should calculate at what he is asking, thermistor. So resistance of the thermistor at 150 we have to find na. So T1 25 degrees Celsius. T2 100 degrees Celsius. So T1 25 degrees at 25 see here. Take second. He has already given that information. He already given that information. At 25 degrees Celsius you got 10K. At 100 degrees Celsius you are having 1K. Next 150 degree Celsius कितना? Don't use numerical ability. You must not use numerical ability. Why? Because it is exponential curve. So you use the same equation. So ln R2 by R1. This time you take this as T2. You can take this as T1. Okay na? So this as R1. This as R2. Initial and final. Okay? Yes or not? I am from Vizag, sir. Okay, Vizag. మరి యూనిట్స్ ఏంటమ్మా? పవర్కి యూనిట్స్ ఏంటి? వోల్ట్స్ అని రాశారు మీరు అక్కడ, వాట్స్ కదా సుభద్ర. चलो, so ln, या समझ में आपको, ln R2 रेसिस्टेंस एट 150 I want by R1 that is 10 kilo ohms is equal to beta value already మీకు వచ్చేసింది అక్కడ beta value. So beta value is how much? 3412. Beta value yeah, beta value 3412 into 1 by T2 at what temperature? 150. 150 means 150 plus 273, 423 minus 298. If you simplify, you will get resistance at 150. Can anybody tell me what is the resistance at 150? Resistance at 150 कितना आ रहा है? No, your mistake is आपने మీరు 4.7 మిల్లీ వోల్ట్స్ అని రాశారు ఫస్ట్. రాయలేదా? సారీ సుభద్ర రాసినట్టుంది. ఓకే, 4.7 మిల్లీ వాట్స్. కరెక్ట్. సో వాట్ ఇస్ ద రెసిస్టెన్స్ ఎట్ 150? ప్లీజ్ ఆన్సర్. రెసిస్టెన్స్ ఎట్ 150 ఎంతమ్మా? రెసిస్టెన్స్ ఎట్ 150 ఎంత వచ్చింది? I think it will be around 339 ohms. Okay, so resistance at 150 will be 339 ohms. So now you can go to the circuit. Is asking the power dissipation na? So but remember this is 339. ikkada china logic undamma. Why? Because this is 339. Now current is also you have to calculate with respect to that. So kaise calculate karna? So power dissipation is equal to I square R. I means at 150. That means how much you can take from the circuit? That you can take it as 5 by 1000 plus 339. 5 by 1000 plus 339 whole square into 339. If you simplify, you will get 4.7 milliwatts. So this is the power dissipation. Got it, dear students? समझ में आपको? स्टूवर्ट क्लियर? चलो, मजा आया? So temperature chapter very easy topic है. Directly we are getting the questions on RTD thermistor. Clear all of you? चलो. निधि यादव, welcome back. So 339 ohms 339 ohms आने के बाद आपको पावर डिसिपेशन कैलकुलेट करना है. सो पावर डिसिपेशन 4.7 milliwatts. चलो, shall we go for one more question? Yeah, please show me your thumbs. All of you got this 4.7 milliwatts or not? That means option B is the correct answer. Option B is the correct answer. Chalo, now try to answer this question. Yeah, see this question. Let me take the circuit first. Yeah, so this is a circuit. So if you see the circuit, so these are grounds are there. Okay, these are grounds. So there is a temperature sensor. This temperature sensor is a circuit is visible for all. Is it visible for all or not? Yeah, very again analog question. It is again an analog question. So this is a temperature sensor. So let us see the question. The junction semiconductor temperature sensor shown in the figure is used to measure the temperature of a hot air. That means what? Whenever a hot air is touching, some current is generated. This op amp is ideal. So this ideal op amp में current नहीं जाता है. So जो कुछ current इधर जीरो है ना, so पूरा current इधर आएगा. And question में क्या पूछा? The V0 is 2.1 volt. He has given V0 में 2.1 volt दिया है. The current output of the sensor is given by equation I is equal to T microamperes. What do you understand from this? कितना temperature है उतना ही current आएगा in microamperes. Where T is in Kelvin. For example, अगर temperature 25 degree Celsius है, that means कितना होता है Kelvin में? 298 Kelvin होता है. That means current कितना होता है? 298 microamperes होता है. समझ में आपको? कितना ही टेम्परेचर है उतना करंट आएगा इन माइक्रोएम्पियर्स. समझ में आपको सुभद्रा जी? चलो. So that is the beauty of this question. Okay, so the junction semiconductor temperature sensor shown in the figure is used to measure the temperature of hot air. The output voltage V0 is 2.1 volt. The current output of the sensor is given by I is equal to T microamperes, where T is the temperature in Kelvin. Assuming the op amp to be ideal, the temperature of the hot air in degree Celsius is dash. Can you do it? 298 milliamperes. Srikant Chandran. First we'll calculate inverting voltage. Yes. So कैसे calculate करना? Simple. See here. He has given 2.1 volt. Let me solve. He has given 2.1 volt. Yes or not? Op amp is ideal. So now if you see the current like this, whatever the current is going, the current cannot enter here. So we can take these two resistors are in series na. This is the current direction. These two resistors are in series na. Now with respect to this particular 1K, if I apply the voltage at this particular, what is the voltage at this particular point? What is the voltage at this particular point? Tell me. These two resistors are in series na. So I can apply 1 kilo ohm by 1 plus 2, 3 kilo ohm into 2.1. You are going to get 0.7 volts na. So this voltage is 0.7 volt means this voltage is 0.7 volt. ये voltage 0.7 volts बोले तो this voltage is also 0.7 volt na. If this is 0.7 volt means this is 0.7 volt na. If this is 0.7 volt means this is 0. Whatever the current comes, that current will pass through the same terminal or not. All of you understood this step? Subhadra, are you understanding this step? Stuart, are you understanding? Vidot Kumar, are you understanding? Srikant Chandan, are you understanding? Once again I am telling this. Listen, these two resistors are in series. Voltage across 1K I have taken 1K by 3K in series into 2.1, 0.7 आया. This voltage same. According to virtual ground concept, this voltage same. If this is 0.7 means this is 0.7. Now 0.7 ये current नहीं जा रहा इधर, so current इधर जा रहा है. So what is the current now here? Current can be taken as V1 minus V2 by R. That means 0.7 minus 0 by 2 kilo ohms. 0.7 by 2 kilo ohms. That will give you how much? कितना आ रहा है? 0.35 0.350 milliamperes. That means 350 microamperes. This is the current. Am I right? Am I right? So, but he has given the current equation as I is equal to T microamperes. So, if you see this 350 microamperes and T microamperes, this microamperes gets cancelled. This microamperes gets cancelled. T you are going to get 350 Kelvin na. That means in degree Celsius how much? Degree Celsius कितना आ रहा है? -273 करो भैया 10 70 कितना आ रहा है? चेक कीजिए 0.35 मिली एम्पियर्स या 350 केल्विन. What is the temperature? 77. So 77 degree. 77 degree Celsius, right? 273 add करो. Correct. 77 degree Celsius. मजा आया? In degree 77 ना? Yes. Why? Because क्वेश्चन में क्या पूछा एक बार दीजिए, एक बार चेक कीजिए. क्वेश्चन में क्या पूछा? क्वेश्चन में the temperature of hot air in degree Celsius पूछा. So temperature of hot air in degree Celsius will become 77 degree Celsius. All of you understood? All of you understood? All of you got it? मजा आया? राहुल जायसवाल, सुभद्रा कुमारी. Okay. Awesome na? So these are some analog questions. Again, transducer plus op amp. समझ में आपको सब लोगों के लिए? चलो ओके ना. सो टुमारो विल प्लान फ्लो चैप्टर, क्योंकि एक्चुअली वन मोर टॉपिक है थर्मोकपल, वो भी करेंगे हम. सो थोड़ा सा टाइम लेके करेंगे. ओके. सो आई होप ऑल ऑफ यू एंजॉयड दिस सेशन. ऑलमोस्ट लेट नाइट का सेशन, 9 to 11 PM का सेशन. ओके. सो टुमारो होगा सेशन, टुमारो 7 to 9 होगा. टुमारो कल का सेशन. ऑल ऑफ यू एंजॉयड द सेशन ना? ऑल ऑफ यू अंडरस्टूड द सेशन ना? थैंक यू सर. 0.7 क्यों लिया? श्रीकांत 0.7 क्यों लिया? इधर ये दोनों रेसिस्टर सीरीज में है ना, इधर वोल्टेज अप्लाई कर दिया. वोल्टेज अक्रॉस दिस रेसिस्टर 1K by 1 + 2 into 2.1. वाई? बिकॉज दिस इज अ सर्क्यूट. समझ में आपको? सो अगर इधर वोल्टेज अप्लाई करो, इधर वोल्टेज अप्लाई करो तो आपको 0.7 आएगा. लव यू ऑल. राहुल पटेल सर, धर्मिस्टर में और कोई इक्वेशन आता है क्या? यस, धर्मिस्टर में और एक इक्वेशन है. धर्मिस्टर में अल्फा इक्वेशन है, टेम्परेचर कोएफिशिएंट ऑफ रेजिस्टेंस का इक्वेशन है, दैट इज -β/T². प्लीज रिमेंबर दिस आल्सो. और एक इक्वेशन आता है -β/T². क्लियर है? यस. गुड नाइट सुभद्रा कुमारी. आसम सेशन. थैंक यू. प्लीज इनिशिएट योर मैक्सिमम फ्रेंड सर्किल. Tomorrow session will be 7 PM to 9 PM. Tomorrow session will be 7 PM to 9 PM. या इंस्ट्रूमेंटेशन वाले फीलिंग आया. सो आपका प्यार ऐसा होना चाहिए. आई एम एक्सपेक्टिंग द सेम लव फ्रॉम ऑल ऑफ यू, so that all these sessions will be benefited by all instrumentation students. ये इंस्ट्रूमेंटेशन लोगों के लिए अच्छा हो रहा है ना. हमारा इंस्ट्रूमेंटेशन कम्युनिटी के लिए जो कुछ 3rd ईयर में है, 2nd ईयर में, 4th ईयर में है, पास आउट है, जो कुछ जॉब कर रहे, इंडस्ट्री में काम कर रहे, जो कुछ लास्ट ईयर में कुछ रैंक आया, दिस ईयर अगेन बेटरमेंट के लिए प्रैक्टिस कर रहे, उन सब लोगों के लिए पूरा यूजफुल है. लव फ्रॉम जमशेदपुर. संजीव, हाउ आर यू मैन? अच्छा, V0 प्लस वर्चुअल ग्राउंड कॉन्सेप्ट. श्रीकांत, this is 0.7, so these are in the same line, so this is 0.7. so virtual ground concept, VGC, virtual ground concept. Sanjeev, virtual ground concept. According to virtual ground concept, V1 is equal to V2. मजा आ गया. चलो, आई एम क्लोजिंग द सेशन बेटा, आई एम क्लोजिंग द सेशन. गुड नाइट टू ऑल. लव यू ऑल. फिर मिलेंगे कल 7 बजे होगा, 7 PM to 9 PM. ओके ना. प्लीज कम टुमारो, विल स्टार्ट फ्लो चैप्टर. थैंक यू. टाटा, बाय बाय. टेक केयर ऑफ योर हेल्थ. स्टे एट होम. हैव ए वेजिटेरियन डाइट. प्लीज डू ब्रीथिंग एक्सरसाइज. मेंटेन सम सोशल डिस्टेंस. बाहर नहीं जाना. ओके घर में बैठो आराम से. गेट एकेडमी का लेक्चर सुन के प्रॉब्लम्स करके रैंक आने वाला है. गुड नाइट. थैंक यू. बाय बाय. या श्रीकांत, करेक्ट श्रीकांत, करेक्ट. V1 is equal to V2. मजा आया. सो प्लीज गिव योर पॉजिटिव फीडबैक. लव सिंबल्स, थंब सिंबल्स, जो कुछ भी दे सकते हैं आप प्यार से वो दो, क्योंकि यूट्यूब का मालूम है ना आपको जो रेटिंग कैसा होता है, लाइक से होता है. सो आपका दोस्तों को भी देख के भी वो आना है. एंजॉय. गुड नाइट. टाटा, टेक केयर. बाय बाय.